Really nice to be with you all. I mean, this is just it's such a great group. I guess, Letwin just said it all, so I'll get right into it. I do want to linger a little bit though on our mission at Radiant Earth. We are sometimes, I think we're an interesting nonprofit. But one of the things that makes us, I think, somewhat unique is that we don't have a strong agenda about how data should be used. We see our role as lowering the cost of access to data, lowering the cost of analyzing data, with the theory that if we can make data easier to access and use, we can make it accessible to more people, and especially people who traditionally have not had access to large scale data, and that is a necessary precursor to enable cooperation on data and cooperation on global challenges. And so we do leave it to the data users, the end users, wherever they may be in the world, to decide how to work with the data. But our job is merely to improve access to data broadly. So I'm going to give a sort of brief history of my career that has taken place more or less over the century so far. I got my master's degree in 2006, and I studied foreign policy, but I was very interested in the internet. I was always interested in technology, and I was kind of disappointed that where I went to school, I went to UCSD. It's a great school. I don't have like any complaints. Sorry, that's the University of California in San Diego. But no one was really talking about the internet. And I could tell, the internet was going to be a very big deal for geopolitics and policy generally. And so I got my master's degree, and then I took a job as like the lowest level job possible at a marketing at a startup that was in San Diego at the time. My title was a marketing enthusiast. Like it wasn't even like any form of professional. Like I was just like an enthusiast. This was the role that I had. But it was great for me because I got to get into the organization, and then I just started talking to the engineers all the time because that's what I was really interested in. I was interested in how internet software got built. And if you look back on that era, so again, I graduated in 2006, all these fascinating things were happening right around that time. So Facebook came out, AWS came out, Amazon S3 was launched, which I'll be talking about later. The iPhone came out in 2007. It's just a really pretty incredible time. And there was all this optimism around figuring out how do we share government data. So I was working, the long story short, I ended up working for the federal government as a consultant, and I was there when data.gov was launched. And I was inspired by this. And as Letwin mentioned, I created Open San Diego. I lived in San Diego at the time, and there was just a huge surge in interest in these kinds of things. Then you fast forward to today, things are really weird. So I think I was right that the internet was going to have a big impact on policy, but now we have things like Doge in the United States, the Department of Government Efficiency, that I'll say on record, I think it's being done in somewhat bad faith to dismantle some governing institutions. Certainly the destruction of USAID, I think, is a travesty, how that happened. And meanwhile, the cloud, like AWS, can afford to give away 300 petabytes of data for free. So it's just, we really do live in interesting times where technology is empowering all sorts of actors to do all sorts of things. And some of that is good, some of that we would say is good, some of that we would say we should be worried about. It depends on who you are. Reasonable people can disagree on how things are going right now. Now, over this same period, though, we've also had some really good efforts to codify sort of what open data is and why it matters. And so data sharing has been written into all sorts of policies. And all the way back in 2003, the National Institutes of Health in the United States started requiring large grants to share data. And then we've had groups create things like the open definition, the 8 principles of open government data, the FAIR principles, and the CARE principles. I think all of these are good things. Like it's good to come up with these definitions. But I am going to, I would argue that having these definitions and talking about, requiring open data policies and things like that doesn't always yield the results that we want. So you can do this at any time in any scientific domain. Just do a literature review, search for papers talking about data sharing, and you'll find that people are constantly writing papers about how Data is usually not that hard. It's usually not that easy to get. People say they're sharing data, but they're sharing it in inconsistent ways. Often the links die out, so there's link rot. So people will publish data, but then it goes offline after a while. And the truth is that we might agree that we should share more data, and that if taxpayers are funding the production of data, then that data should be open to the public. But it's hard to publish data. I think we're just learning the hard way that this is actually a craft and a skill that is difficult. And I think we've made a lot of assumptions around how technically easy it is. And we argue that it's actually a really important skill and craft that we need to be funding more. On the other side of, I would say, just maybe the economy. So in the private sector, we've also had a lot of magical thinking around data as well. So I'd just say, like, I do like to pick on my colleagues who, those of us who work in the data for good space. But I think it's also good to pick on the people who are trying to make money off of data. So The Economist published this in 2017. This is where the idea that data is the new oil came from. And what The Economist was saying in this piece was not comparing data directly to oil, but comparing the big data firms to the big petroleum companies or fossil fuel companies, and pointing out that these companies have enormous power and they need to be regulated the way that fossil fuels are regulated. And that nation states need to be aware of the power that's emerging in these large technology companies, these large data firms. What most people have heard, and I hear this still all the time, people completely miss the point. They say, oh, data is the new oil. That means if I get data, I can make money. And that has led to a lot of silly business models that are completely incoherent, where they say, okay, we're going to get some data, and then something will happen, and then we'll make money. And this very, very rarely works. So oil is a fungible commodity that, if you do have it, it's worth something and you can sell it. Data is not like that. Some data is valuable. A lot of data is not valuable. Probably most data is not valuable. And making money off of it is extremely difficult. And so the point is here is that I think a lot of people have been wasting time with a lot of magical thinking, thinking that if you open up data and make it available for free, good things will happen. Or if you get a lot of data, you'll be able to make a lot of money off of it. So we have a trick for this that we use at Radiant Earth, is that we refer to data. We rarely talk about data in the abstract, and we really try hard to talk about data products. This is just a linguistic trick that we found that works really nicely. I wrote a blog post about this almost 3 years ago now, where we just said, look, we don't really talk about open data here. And we like to talk about data products, because if you think in terms of products, you have to think about who your users are, what their experience is. You have to think about the maintenance of that product and getting it out to the market and things like that. So simply talking about data products has turned out to be a very useful hack for us in order to kind of sharpen our thinking when it comes to how we share data. And then the other thing is that it helps us have a much more nuanced, I think, and practical conversation around things like the FAIR principles and the CARE principles. When you're trying to make data findable, accessible, interoperable, reusable, or reproducible, I can never remember what the R stands for in CARE, or sorry, in FAIR. And then for the CARE principles, I also don't remember what the acronym stands for, the CARE principles. I keep forgetting it. But the point is that with the care principles is there are ethical considerations around the data, understanding who are the populations that are represented in the data, are there considerations and needs met, and things like that. The truth is that you have to think about these things very deliberately at the data product level. So it's not easy. You can't just say, like, is your data fair or does it follow the care principles, as if there's like kind of like a binary yes or no, it does. The truth is that the considerations for to understand if you're meeting those principles. Oh, thank you, Stephen. Stephen put it here. The care principles for indigenous data governance are collective benefit, authority to control, responsibility, and ethics. And there are papers about these things where they define these things. But the point is it's much easier to have these conversations around the ethical considerations and the usability and accessibility considerations for data sets based on the data product itself. And so what I use this graph for is just to kind of point out that there are data products that are extremely large or complex, and those are technically challenging to share. But in the case of like Landsat data, there are very few ethical challenges to sharing Landsat data. They're not none. I don't want to say that there are none. Moderate resolution satellite imagery is somewhat safe to share at large scale. A lot of environmental observations are safe to share at large scale. And so they might be technically difficult, but the ethical challenges are not that hard. If you have people's health data, that might be trivially small data that's easy to share just as like spreadsheets. But the ethical considerations of sharing that are very difficult. So all this is to say that the concerns about how we share data and the principles that we're defining, they're really contingent on the individual data sets. Anyway, we just need to remember that. And I think this is a useful frame to do it. And then finally, this is a paper that I really like. This is written by two economists at the Yale School of the Environment. Eli Fanichel is one of our advisors. But the title of it is wonderful. It's just, why should data be free? Don't you get what you pay for? They are, Eli and David are economists, and they just point out in this paper very eloquently that it is somewhat incoherent, at least to an economist, to say that something has a lot of value and that it should be given away for free forever. And I think, this is an unfortunate and an inconvenient truth, is that producing data and sharing it is expensive. And yes, it's nice that some rich countries can give data away for free at scale, but there are a lot of countries in the world where that's a completely unreasonable expectation. What's more, I think the concerns around data colonialism and asking countries all over the world to share their data openly and, just trust us, it'll be fine. I don't think that's really coherent or a good thing to do. So in any case, I've been an open data guy my whole career, so I feel like I have license to say these things. The other thing I want to talk about is the sort of like the what is a data product or what makes a good data product. We live in a really exciting time right now because of large language models, because they're making the cost of producing tools and applications very cheap. Historically, though, one thing that we've seen a lot is that we've seen a lot of the production of like dashboards and applications and things like that, APIs, services that are designed to make data accessible. And so the way I characterize what's happening is that if you have data that is not processed, so it's all the way over here on the left side of the graph, its potential value is limited, right? If you're taking data straight off of a sensor and it's not documented and you haven't, turned it into formats that most people can use, the audience for that data is going to be quite limited. Historically, the way governments and nonprofits are funded on sort of a project basis, a lot of data initiatives have overdetermined how data should be used. So what will happen is they'll say, you know what, we need a tool that can really help Kenyan farmers or, land use managers in Vietnam or something like that. And you end up overdetermining what the data can be used for, and you end up with a dashboard or an application that is, appropriately based on, project funding, designed to solve a specific need and designed, to have a specific impact. It makes sense that funders, they want to have impact. They want to be able to articulate that impact and understand who they're reaching. But this comes at a cost, because if you're building an application or a dashboard or an API, you're making decisions about how the data should be interpreted. And you're limiting the potential value of the data. So in our opinion, this is a very scientific term, we aim for this sweet spot somewhere before that, where data is made reliably accessible in commonly used formats, non-proprietary formats with good metadata and documentation, and then just stop there. If you can make data products available in that somewhat, we'd say par-baked, I don't know if you know that term, but like, half-baked way, then anyone can take that data and go the extra mile to whatever level of processing they want, or to build whatever kind of application they want. And in 2026, with large language models, it's unbelievable now what people are able to do if they just have access to this data that's properly documented. So this is the way that we see things, should go. I'll take a brief detour, down, Landsat road, but this is what a Landsat scene looks like. Historically, when you would get a Landsat scene, you would have to download about a gigabyte of data. You'd have to get all of this data to get it out. That was, the way Landsat was offered. A tar archive, you'd get a single file that was about a gigabyte before you could do anything with it. When I was at AWS and we started looking at Landsat data, this is now 11 years ago, we thought, this doesn't really make sense. We shouldn't ask people to download a gigabyte of data if they don't need a gigabyte of data, especially in countries, in places that don't have great connectivity. This is a huge tax in terms of time to just interact with data. And so we said, why don't we make the individual TIFF files available and then even go a step further and make it so that you can fetch out only parts of those TIFF files. And that was the beginning. We didn't call it the cloud optimized GeoTIFF at the time, but we made Landsat data available in that way. And then that pattern has become codified by the community, mostly led by Chris Holmes, who gave it the name the cloud optimized GeoTIFF. And now it's a very common, way of working with data. This is a graph I always like to show from Drew Bollinger, who was working at Development Seed at the time, created this graph where what you're seeing here, it's hard to understand. It's not labeled well. Each of the points on this graph represents the time spent to process a Landsat scene. And Drew was working on a project where he was processing 90,000 Landsat scenes. And what you're seeing here on this left side, this cluster that's up here, is that before we released Landsat data in the cloud optimized GeoTIFF, it took about 400 something seconds to process a scene. And then after we made the data available in this way, that dropped down to something like 20 seconds per scene, 25, 50 seconds per scene. Our estimate on the math represented here is that this saves something like 250 days of time in processing just by improving the access to the data and shortening that time. And this is what we're talking about when we talk about making data easier to access and use, and the benefits of this that this can have. It can really accelerate research. The good news these days also is that data products are really starting to take shape. So, historically, people have not quite known exactly how to share data. Do I have to build an app? Do I have to, create an API? We have things like Harvard Dataverse, Zenodo, Dryad. We have a product called Source Cooperative. All of us are starting to take shape in terms of data products are often shared with like a description, some documentation, information about who produced them and things like that, and a bunch of files to download or to access. But the point is that we do finally we're adopting a form of what data products should look like, and it's roughly this: a title, description, a digital object identifier, ideally, and a lot of files. I like to point out to people that we are lucky to have many centuries of experience with books. And one really interesting thing about books, if you think about it, is that books carry a lot of metadata with them that we all understand. So all of us have a pretty good understanding of knowing how to decide if a book is good. We do judge books by their cover. We know who the authors are. Sometimes we pay attention to who the publisher is, the price of the book, the number of pages. These are all relevant signals that we understand to decide like if a book is something that we want to buy or not. And what's even more interesting is that there are people in this world who it's their job to review books, to tell us whether books are good or not. So this is, it's just an interesting precedent to look at. We even have had for a long time professional societies of people that work in bookmaking. And this is a book from 1919 where the Society of Calligraphers did an analysis of how what makes books good. They wanted to understand like what makes a book appealing physically. And one thing I argue is that we need to do much more of this kind of meta science on data itself. That's why I like this term, data product, is that if we do have an understanding of what a data product is, we can start coming to an agreement on how do we know if a data product is good or not. So this is a funny little twist here is that I think the word great is much better than open. So rather than talking about open data products, even though, open data products exist, I don't think it's necessarily very interesting if data is open. I want to know if it's great or not. Um, Great is a very funny word because it's hard to define. It's not a very precise term, but we do kind of know what it means. There are great books, there are great movies, great songs. It's a nice sort of like directional adjective. It's like we want things to be great. I don't know if any of you know who Eleanor Ostrom is, but she was an economist. She won the Nobel Prize, who did a lot of research on how people share common pool resources like fisheries, forests, grazing land, things like that. A lot of her work focused on the fact that she disagreed with the idea of the tragedy of the commons, that she disagreed that we live in a world where either the state controls everything and metes out access, or we let the commercial sector figure out how to distribute goods. She knew that people had historically figured out ways to share resources commonly. I don't know if she ever said this in, verbatim, but this was kind of the thrust of her work. It's come to be known as Ostrom's law, which is that if it works in practice, then it can work in theory. And I say this now because I think we do have evidence of great data products. And so we should study what are these great data products and understand what they are. There's a fantastic paper called Data Science at the Singularity, came out a few years ago, where the author proposes that one of the reasons why AI has taken off as rapidly as it has is because the AI community, research community, has attained a level of what he calls frictionless reproducibility, where there are a number of data products that are great. Things like you may have heard of these: ImageNet, Common Crawl, Coco. There are a few sort of like canonical data products that the AI community has centered around, and it's allowed them to accelerate their research. They've really put sort of the FAIR principles into practice in a remarkable way. And it's a paper that I think really articulates the need for investment in better data products. Also, we have a podcast about this. So we do every month. I call it a live stream webinar podcast thing. You can watch live if you want, but then we also put the audio out on a podcast feed. But it's just called Great Data Products. You can go to greatdataproducts.com, where we post everything there. And we did an episode just 2 days ago that we still need to put up on the website. All right, really want to get through this because I want us to have questions, but I apologize. I just have so much to say, so I'm just going to keep going. The really important, I think, issue of our time is understanding how do we manage the infrastructure used to share products, data products. One is just the fact that like openness, I think the term has become really abused. Also, this is a paper that I didn't write, but I edited, so I wish I could take credit for this phrase, but I wasn't the author of this one. But openness is today being used by companies as a rhetorical wand to lobby to entrench and bolster their positions. I love this idea of a rhetorical wand, but it happens all the time. You'll have initiatives that say, "Oh, we're open," or they'll have a company where open is in their name, and it's clearly being used to kind of bedazzle people and let them, have them believe like, oh, if it's open, it must be a good thing. So we could call this open washing. And then another, phrase that I think is fascinating is the term democratize access. I will say, I've been an open data guy. I've also been a democratize access guy for a lot of my career. I've really bought into this idea that we should democratize access to things. I still believe that's true. When I talk about democratization, I believe that it's a matter of making more people more powerful, just giving people power and agency over their lives and their communities. But within a technology context and in terms of a platform design context, what often happens is a platform will democratize access to something. For example, YouTube is a great example. YouTube has democratized access to publishing, to broadcasting globally. We use YouTube for our Great Data Products podcast. They have really democratized access to broadcasting and video publication in a really amazing way. And now I'm completely dependent on YouTube. Our business, our operations depend on YouTube. And so it's this kind of, sneaky thing where you democratize access to something, and as a result, what you're doing is you're capturing a lot of people. You're giving them capabilities, but then they rely on you for those capabilities. And we just need to be aware of this dynamic because it does give the democratizer a lot of power over their users. There's this link here is to a blog by a woman named Denise Hearn, who really sort of opened my eyes on this. I really highly recommend it. So our position on how to share data, and as we think about platform governance, is that data sharing should be done using commoditized cloud object storage. And this is where I'm aware that I become extremely boring and nerdy in it's a very specific way, but this is I believe this with every fiber of my being that object storage is the path to sharing data. I'm actually going to blow through this really quickly because I do want to leave time for questions. We work with Harvard's Library Innovation Lab, and they've worked with us to share, some huge corpuses of data. And one of the reasons they like working with us is because we do encourage the sharing of data as a large corpus, but then also allowing individual access to files. And that's one thing that you're able to do with objects is you're able to share data not only as individual objects, but also allow people to stream those objects out. It also allows people to build interfaces on top of it. So Harvard's example here is a great one in that here on the left, you sort of see what a data product looks like on our data publishing utility, which is Source Cooperative. It's just a bunch of files, but because it's built on object storage, which is highly commoditized and integrates with just about anything, Harvard was able to build a browser interface that is extremely cheap. It doesn't actually require a server at all that can create a search interface to all 17 terabytes of data that's in this archive of data.gov. And that's made possible because of object storage. This is also sort of what Source can look like in practice. We allow for the streaming of all sorts of data. This is what's called a PM tiles file that includes several billion building footprints that are easily streamable and viewable in the browser. This just looks like a table down here, but you'll notice this is 1.6 million rows of data, and you can stream that out of an object store and access, very large data very easily. And then this over here is a GeoTIFF. We're really proud to work. We work with a group called Taylor Geospatial that is, I think, doing some fantastic work to make really large scale data sets available at global scale, so planetary scale data products. And so anyway, we publish a lot of data for them on Source, and should just be aware of those. The other advantage of object storage is that it integrates with everything. It's become a de facto standard for things. And so if you search GitHub for our endpoints, for our URLs, you can see if people are referring to data. This screenshot's a little old. It's now over 1,000 results that come back. And actually, just earlier this week, I did some analysis with help from Claude Code to analyze all of the files and to see, how are people using the data. And so this is a really nice thing using an object storage based approach is that any programming language has a way of accessing object storage. And so it's designed so that people can build code on top of it. And we can see which data products are the ones that are like actually being used and track this kind of thing. And hopefully learn, going back to Eleanor Ostrom, see what's working in practice and then, back out of that and understand, well, what is it about these data products that makes them work? Can we develop theories to understand what makes these ones so great? And so, yeah, there's a lot to learn here from looking at this kind of information. And I'll try to land the plane here, but there's just one other point on sort of geopolitics and sovereignty issues is that I cannot emphasize enough that sort of how important it is and how significant it is that object storage has become commoditized, that it's become a de facto standard. There's a fantastic post by a guy named David Eves who makes the argument that as countries, seek to have sovereignty over their technology, they absolutely should do that. But they need to align, there are huge benefits to be gained by aligning around established patterns of technology. So what we don't want to have is to have every country launch their own cloud that is not compatible with other countries. It'll lead to, silos and balkanization of technology, which is, the last thing that we need if we want to address things like pandemics and climate change and human rights and supply chains and other supply chain issues and things like that. And so we believe that, that object storage is the way to do this. The pattern for using object storage was established by Amazon S3 about 20 years ago, but it has become the de facto standard of how to do things. And it's a very simple, primitive way of doing it. This is just a chart showing that, the cost of S3 declined dramatically over the first 10 years that it came out. And then you fast forward to today. This is a chart produced by one of our fellows, Brandon Liu. We have a couple dozen object storage service providers that are all providing functionally the same service. And there's a lot of downward competition on price. And I averaged all this out, and we're somewhere around, 1.5 cents per gigabyte per month to store data. And it's amazing that we know how to do that math now. Just 5 years ago, 10 years ago, it really wasn't that easy to answer this question. Like, how much does it cost to share a gigabyte of data anywhere in the world for a month? It was complicated math. But the market has really driven the cost down to sort of a stable place. And, we can assume they're going to keep going down. So this is a huge question for us at Radiant Earth, and something we focus on quite a bit is this, especially in 2026, the past few years I think have been quite turbulent, and, a lot of data has been proven to be at risk, data that was provided by a source that a lot of people assumed was reliable. It's not that reliable. And so we need to figure out, how do we make more reliable data offerings? The repositories that we've had that rely on federal, grant overhead are quite fragile. Of course, we know that, government budgets can change. And so we need to find another way to make things more durable. We like the idea of an endowment. If we were to endow a bit of infrastructure like Source Cooperative, and so we are thinking about this for ourselves, to, have us on very solid footing in terms of having engineering staff, customer support staff, basically everything that we would need to really ensure that data is being safeguarded and secure and is reliably accessible. We could potentially ensure that data is made available forever. We created this model where we just took S3 pricing, which is quite expensive, actually. I mean, it's one of the more expensive offerings from the table that I showed you before, and then add some markup to it so that accounts for bandwidth costs. But the math that we worked out is that if you wanted to store data for forever and have it be paid for by an endowment, just the interest that you get off of a big investment, it costs about $30 to endow 5 GB of data for forever. And then if you, multiply that by a lot, if you wanted a petabyte of data, it'd be about $5.5 million, but one time that you would pay, and then that data could be made available forever. There's a lot of nuance here. I actually think this is a very conservative model, and that these costs could go down, but it's an interesting thought exercise. And I think it's an interesting thought exercise in perspective, putting it in perspective of other, the way we spend money on other things. It's a relatively small investment relative to the investment in producing data. If you're going to be producing data, you should put, a portion aside to ensure long-term access, and you could add to the endowment to do this. Forgive me, there's a typo here. So I'm putting a $65 million endowment in perspective. The math keeps going up. So we have 4 petabytes of data in Source. If we wanted to endow that forever, along with our operational, staffing for forever, let's come around to $65 million. Now, have I ever asked anybody for $65 million? No. But the point of this thought exercise in this slide is to point out that we, for better or worse, live in a world where we do have some philanthropies and some billionaires that do give away a lot of money. And in perspective of the amount of money that they give away constantly, this again is a fraction of what they're doing. And then also we have very, very large incumbent environmental nonprofits that they spend multiples of this kind of money every year, which I think it's interesting. So I'll close with this quote from John Wilbanks, a great friend who has been very thoughtful about this. Without a change in how we organize scientific research itself, we won't be able to use these developments in data generation and modeling at scale. Science is often organized around the laboratory, the principal investigator, and the publication, rather than data, software, and computational power. And so you'll know by now, I think we really do need more funders that understand that investment in great data products is essential for us to cooperate on things and for us to accelerate research. So I see some questions are coming in. So thank you all for sticking through that, and also for